Hello everyone, let's solve a problem from GATE 2023 question number 42 from Aerospace Engineering paper, right? Considering the equation dy by dx plus ay is equal to sine omega x where a and omega are constants. Given y is equal to 1 at x is equal to 0, select all the correct statements from the following at x tends to infinity. So option 1 is if a is not equal to 0, y tends to 0. If a is equal to 0, y should tend to 1. If a is less than 0, and y should tend to a e power ax. If b and a is greater than 0, then our y should become b sine omega x plus c. So let's go and solve the problem and find the solution for y, and then use that solution to check whether if any of these options are right. Okay, let's first go and solve the problem. The form that's been given to us is dy by dx plus ax is equal to sine omega x. First we have to find the roots. For that we'll just take d plus a equal to 0, which will give us d is equal to minus a. Then our complementary function will become c1 e power minus ax. Then we have to find the particular integral, and we will get 1 by d plus a sine omega x. Okay, for then we have to take the conjugate, then we will get d square plus a square sine omega x. Right, now this becomes differentiation of sine omega x will give us omega cos omega x minus a sine omega x. In the denominator we have to replace d square by minus omega square. Okay, this coefficient has to be replaced. Minus omega square minus a square. If we have to take this to be positive, then we will get a sine omega x minus omega cos omega x omega square plus a square. Okay, so then our solution becomes c1 e power minus ax plus a sine omega x minus omega cos omega x omega square plus a square. Now we have to find the constant c1. For that we have been given a boundary condition at x is equal to 0, y becomes 1. Okay, let y of x is equal to 0 equal to 1. If we substitute that, 1 c e power 0 plus a sine 0 is 0 minus omega cos 0 is 1, cos 0 is minus 1, cos 0 is 1, omega square plus a square, then you will get c1 to be 1 plus omega by omega square plus a square. Okay, then our y becomes 1 plus omega by omega square plus a square e power minus ax plus a sine omega x minus omega cos omega x omega square plus a square. Okay, first let's go to the options. So first two options are a is equal to 0 and a is not equal to 0. First let's take a scenario of a is equal to 0 and x tends to infinity. What we are getting, if we substitute a is equal to 0, then we will get 1 plus omega by omega square, and e power 0 is 1, right? So this term goes to 0 because a is there, omega cos omega x by omega square, a square becomes 0. Okay, so omega get cancelled, then we get 1 plus 1 by omega minus cos omega x omega. Okay, as you can just see, the cos omega x will lie between minus 1 and plus 1. So there will always be a value of 1 plus something when A is equal to 0, right? But the option that's been given is y tends to 1. That's not the correct solution. Okay. If A is not equal to 0, what we will get? If A is not equal to 0, then we will get this whole term will not become 0, right? So at e power minus infinity, this term may go to 0, but we will have a trigonometric term which will lie between minus 1 and plus 1, which is not again equal to 0, right? So this is also not the correct solution. Okay, so one of C and D or both of them has to be correct, right? So let's go write it in another form. So in order to A sine omega x minus omega cos omega x A square plus omega square. If you consider this to be A and omega, then this hypotenuse will be A square plus omega square. If you consider this to be theta, okay, then our cos theta will become A by root of A square omega square plus A square. Our sin theta will become omega by root of omega square plus A square. If we just substitute, instead of A by root of A square plus omega square, if we just substitute cos theta, and instead of omega by A square plus omega square, if you substitute sin theta, then you will get C1 e power minus AX plus cos theta sin omega x minus sin theta cos omega x. So this will become divided by root of A square plus omega square. So this will become sine of omega x minus theta. Okay, C1 e power minus Ax plus sine of omega x minus theta by root of A square plus omega square. So now if you just substitute A is greater than 0, what will become? So it has to be a positive value. Then as x tends to infinity, y this c e power minus infinity, this goes to 0, then our minus theta by A square plus omega square. This is what will remain. Okay, since sine of any value will remain between minus 1 and plus 1, so this term will remain, right? So if we go to the option, we have b sine omega x plus c. Okay, let's consider b to be 1 by omega square and c to be minus theta. Then what we will get? B sine omega x plus c, right? So this is the term that we are getting as a greater than 0. Then if we go and analyze a is less than 0, what you will get? Y is equal to c e power, already minus is there, if a is less than 0, this term will become positive, and then we will get sine omega x minus theta by root of a square plus omega square, right? So as x tends to infinity, this e power ax will keep on growing. It will get a larger value, it will keep on multiplying and then get a larger value exponentially. So when you compare to this term becomes very small, and then we can just say y will tend to c e power c1 e power ax as x tends to infinity and a is less than 0, right? If we just take a c1 to be a, then we will get the option of this form, right? So hence both C and D are the correct answer to this question, right? So if you want to know more about similar concepts, you can refer to the NPTEL course Engineering Mathematics 1 by Professor Jitendra Kumar from IIT Kharagpur, and you can also refer to the lecture number 57, which is solution of higher order homogeneous linear equations. So you can also see the YouTube link for the particular lecture here. So that's all for this question. Thank you.